Hi, everyone. Welcome to section 11.4. This is Nick Jacobs, your intermediate algebra instructor here at Yavapai College. And in the final section of chapter 11, we'll talk about the quadratic formula. So the quadratic formula is basically a one-stop shop to be able to solve quadratic equations. Now, we've learned how to solve quadratic equations using other methods. We've graphed them, we have completed the square, we've used the square root property, we've factored them and then used the zero product property after that. But again, the quadratic formula is basically a way to solve any quadratic, especially ones that don't give us nice numbers. So let's go ahead and I'm going to talk about some more objectives here. So we're going to solve quadratic equations primarily using the quadratic formula. We're going to find and apply what we call the discriminant. And that's basically part of our quadratic equation. And I'll talk about it here in a little bit. But basically, the discriminant tells us how many solutions a quadratic will have. And we'll get to that again in a second. We're also going to use intercepts to graph quadratic functions. So again, we're just gonna kind of be looking at the graphs of those and kind of verifying it with our quadratic formula. And then we're also at the end going to solve some quadratic equations that have complex solutions. So when we completed the square, primarily last section, I know we covered it in a little bit of 11.2, but we didn't run into any completing the square problems that could have given us a complex solution. So we're going to do that today as well. So the quadratic formula. Okay, so here it goes. Basically, the solutions are really any solutions, even complex. Okay, and we'll kind of find this out. Any solutions to a quadratic, right? Remember, this is a quadratic, right? When we have an x squared term. Any solutions are given by this formula. Here is our formula. This is our quadratic formula. This is just a period here at the end, but this is our formula. It's x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's our quadratic formula. You've probably seen it at some point in the past. If not, if this is new to you, that's fine. I'm going to kind of treat it like it's new. If this is review, you can kind of, follow along, go over some examples. But if not, we're going to be doing this. We're going to be doing some examples and learning how to solve quadratics using this formula. So here I give you a quadratic equation. It's x squared plus 3x minus 10 equals 0. Now again, we could use any of the methods that we've learned so far to solve this. We could factor, we could graph, we could use completing the square. We could, well, maybe not, we can't use the square root property, but any of the other ones we could use for this, okay? And I'm actually going to show you a few different things that we could do. So we could factor this. Now, in this case, factoring is probably going to be the easiest thing here that we can do. But I also want to demonstrate that in a problem like this, we could also use the quadratic formula. So let's go ahead and factor this. We know here, this is very much review. We need factors of negative 10 that add to 3, and those would be 5 and negative 2. So it would be factored as x plus 5 times x minus 2 equals 0. And then we would use the zero product property. Basically, we would set both of those factors equal to 0, and then we would solve it. So one of the solutions is x minus 5, and then the other solution is x equals 2. So basically, your solutions are x equals negative 5 and 2, or just negative 5 and 2. Okay, so we know that this is going to be the solution. Okay, but let me demonstrate how to use the quadratic formula to find that. Okay, so we know here that our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, okay? And we know here that the standard form of a quadratic is ax squared plus bx plus c equals 0. So then what we need to do first in this equation down here is we need to find what a, b, and c are. So in this equation, what does a equal? Okay, what does b equal? And then what does c equal? Well, a is just equal to 1, right? It's the constant or the coefficient in front of x squared. So a is equal to 1. What does b equal? Well, b is equal to 3. It's the number in front of x. And then c is equal to this whole negative 10, minus 10. So all I do is I go ahead and I plug these in, or I substitute them into the quadratic formula for b, for a, and for c, anywhere that I see those. So I have negative b. So that means I have negative 3. So I substitute in the 3, plus or minus b squared. So I'd have 3 squared. And I always use parentheses, by the way, minus, even here, parenthesis 4. So 4 is just part of the problem, times 1, which was our a value, times, let me extend this radical a little bit, times negative 10. So this is all under the radical, okay? And then all over, so all of this stuff, including the minus 3 plus or minus this radical, all over 2 times a, so all over 2 times 1. So now what I'm going to do is I'm going to simplify this. So I have negative 3 plus or minus. Let's simplify inside the square root. I have 3 squared. 3 squared, 3 times 3 is 9. Now I have basically a minus 4 times 1 times negative 10. Well, that's going to actually give me a negative 40 when I multiply these 3 together. And then this sign is going to give me a positive. So this is going to be plus 40. And you can think of that as I have a minus 4, positive 1, minus 10. So I have 2 negatives in here. Well, multiplying 2 negatives together gives me a positive. So that's how it ends up as positive 40. And then all over 2 times 1, so all over 2. And then I'm going to keep going. I'm going to simplify what's inside the radical. 9 plus 40 is 49. And then let me bring this up here just a little bit. I would have negative 3 plus or minus, what's the square root of 49? Well, the square root of 49 I know is 7. And then I'm going to break this up. So basically I have x equals what? Well, this plus or minus gives us 2 different solutions, okay? So one of them is plus, so negative 3 plus 7 all over 2, or I could say and, actually, and x equals what? X equals negative 3 minus, right? Minus 7 all over 2. So really our solutions are, well, negative 3 plus 7 is 4. 4 divided by 2 is 2. So it's 2, and negative 3 minus 7 is negative 10. And a negative 10 divided by 2 is negative 5. So our 2 solutions are x equals 2 and x equals negative 5. Just like I got when I factored it over here. So this was a lot of work. This was a lot of work to do our formula, okay? But again, this quadratic formula is going to work anytime. So even if it's not factorable, I can still use the quadratic formula to solve this quadratic equation. And another thing that I can do is I can graph this as well to check, okay? So let's actually go ahead and do that. So I'm going to go ahead, go over to Desmos quick here. Remember, we've been using Desmos a lot in class. If you have a graphing calculator, you can definitely do this as well. But you have, for our function, we have x squared plus 3x minus 10, okay? So here is our quadratic. And remember, we learned last section, or maybe a couple sections ago, on what the solutions of a quadratic are. And the solutions of a quadratic are where it touches or crosses the x-axis. So here is our x-axis, this darker line here going horizontally. I can see here that this crosses at -5, 0, and 2, 0. So that's where we get the solutions, -5 and 2. Okay. So let me go back to our PowerPoint. So then, another way you kind of you could express these solutions are you could express them instead of x equals -5 and 2. You could express them as whoops, not x, but you could express them as points, right? So -5 comma 0 and 2 comma 0. So that would be another way to express the answer. But generally, when we're doing a quadratic equation, because we have x over here, we just say it's x equals. Okay, so we generally don't use the points, but I did want to emphasize that yes, those points are answers, okay, are another way to express the answer. All right, let's do another one. Using the quadratic formula only kind of this time, and then we'll also check the answer graphically. But my point is, in this case, this is not factorable. How do I know it's not factorable? Well, remember early on we did in chapter 6, we did 4 times -8, which was -32. Well, there are no factors of 32 that give us a +3, and I could check that. I have 1 and 32, 2 and 16, 4 and 8. Okay, none of those are going to give us a +3, no matter which one that I make negative. Okay, so when I do this, what I have to do here is just recognize that, yeah, I'm going to have to use the quadratic formula. Again, another way to do this is to complete the square. But for this one, if I would complete the square and I would factor out something here, well, if I divided all these by 4, what would happen, right? I would actually end up with a fraction here, 3/4, and we don't really want to work with fractions. So let's go ahead, let's use the quadratic formula. I know in this case that A is equal to what, B is equal to what, and C is equal to what. That's kind of how you start off with. And I know that in our remember our regular kind of standard form of a quadratic, that I have ax squared plus bx plus c. And I know that a here is the coefficient in front of x squared, so that's 4. Comma, I know that b is equal to 3, and then c is equal to -8. Okay, so then what I do here again is I take my quadratic formula, and it's probably good to have this memorized, and you probably will after this section, but or if you don't already have it memorized. But I copy down the formula. If you don't need to, if you don't want to copy it down, you don't have to if you know it. I'm just suggesting that. So copy it down and then substitute. So I have -b, so I have -3 plus or minus the square root of b squared. So that would be 3 squared minus 4 times a times c. And if you need to extend the radical a little bit, you can. We've got to emphasize that all of this is, excuse me, is underneath the radical. And then all over 2 times what? 2 times a, which is 2 times 4. So now let's simplify. So I have the -3 outside the radical, plus or minus. Let's find out what all this is. So, well, 3 squared is 9. And then I have a -4, +4, and then -8, multiplying all of those together. And I'm kind of cheating a little bit because I already wrote down this one, but it is 128. And it's a positive, again, because I have 2 negatives. And then 2 times 4 is 8. And then we can keep going. And in this case, 9 plus 128 is 137, which is not at all a perfect square. And it also can't be simplified. So what you do here is you can break this up. So I can say one of the answers here is x is equal to -3 plus the square root of 137 all over 8. And the other answer here is x is equal to -3 minus the square root of 137 all over 8. So those are your 2 answers. You don't really need anything else in there. but that's what we would do. And then sometimes they ask you also to just estimate your answer to the nearest tenth or something. So if you typed in this one on your calculator, -3 plus the square root of 137 over 8, you would get about, let's round to the nearest tenth, 1.1. And then the other one, you would get about -1.8. So again, these are going to be your exact answers. We kind of talked a little bit about that in the last section. And then these are going to be your approximate answers over there. Okay. So either way, that works just based on what they ask you for on your homework or quiz or test. And then graphically, if you graph this on Desmos or something, you would get something that looks like this. So again, this one, unlike the last one, this one does not show up or does not cross the x-axis at nice points for us. And again, that's another reason to use the quadratic formula, because this doesn't cross at nice points. And you know, I could let me just go on to Desmos and kind of show you here. So again, our last one crossed at very nice whole number points, -5, 0, and 2, 0. Well, this one, if I graph it, let's see what happens. We have 4x squared plus 3x minus 8. And again, it gives us 2 points, but it rounds those answers. Okay, so -1.838 and then 1.088. So could you use Desmos for this? Yes, you could, but it would not give you your exact answer. Excuse me. So it would not give you these answers where we have the square root in there, and you have to know how to do that. All right, let me go back to our PowerPoint and let's do another one. So, and the point of doing another one is because this is going to have actually one answer in this question. So if you want to, you can do this by yourself. You can pause the video if you kind of know the quadratic formula, if you don't need more practice. Otherwise, you can kind of watch what I am doing here as I demonstrate how to do this. So again, if I'm using the quadratic formula, I need to pick out my A value. In this case, it's 3. I need to pick out my B value. Here it's -6. And then C is equal to 3. So then if you want to, you can copy down the quadratic formula. So -b. And I just copied it wrong. If you noticed my mistake there, I put a b to the 4th, but it's -b plus or minus the square root of b squared minus 4ac all over 2a. And then we substitute here. Now, the thing about this one too is I have a -b here. Well, b is already negative. So this would be a negative times a negative, which is actually going to make a +6, right? And then plus or minus the square root of b squared. So -6 squared minus 4 times a times c. So 4 times 3 times 3. And then all over 2 times a, so 2 times 3. And then again, this initial term here, negative times a -6 is going to give us +6. And then inside the radical, I have 6 squared, which I know is 36. 4 times 3 times 3, that is actually 36, but it's minus, right? So it's going to be -36 because I have one negative. And then all over 2 times 3, which is 6. Well, look what happens here. What's the square root of 36 minus 36? Well, that's just the square root of 0. And we know that the square root of 0 is just 0, right? So it's 6 plus or minus 0 all over 6. Well, 0 can't be plus or minus. So really, our answer is just 6 over 6, which is 1. So x is equal to 1 in this case. Okay. And if we, so what does that tell us? Well, that tells us that our quadratic is only going to touch at x equals 1. Okay. So it's not going to cross at 2 different points. So our quadratic here, let me type this guy in, 3x squared minus 6x plus 3. And look, there's our quadratic. it is crossing or it's touching actually on the x-axis at 1. Okay, or at x equals 1. So that's where we get our solution for this. Okay, and I had a graph right here for this one. I just I kind of wrote over it here, but you guys kind of get the idea. I can well, I'll keep that. I'll keep the graph in there for now, I guess. You guys kind of saw the video on it. So this one, whoops, I guess I didn't mean to have the graph in there, but the point is on this graph, what do you think the solution is going to be here? So I have the equation 2x squared plus 4x plus 5 equals 0. Now I already graphed this right here. Okay. Think back to last section. What happened when our graph did not touch across the x-axis? How many solutions are you going to have to this? Well, you're not going to have any, right? Because if your quadratic does not touch or cross the x-axis, you have no solutions, okay? So this will not have any solutions. Let me change the color. So this will have no real solutions, okay? And let's show, and that's because the graph does not touch or cross the x-axis, okay? Now, let's use the quadratic formula to see what would happen in a quadratic formula for that to happen. So our value here for A is 2, B is 4, C is 5. Now let's go ahead and let's use our quadratic formula and let's plug in all of these things and see what happens. So I have -4 is the B, right? Negative B, plus or minus the square root of B squared. So 4 squared minus 4 times A or 2 times C or 5. All over 2 times A or 2 times 2. Well, let's look at inside the radical. So 4 squared is 16. Now, what is 4 times 2 times 5? Well, that is actually a negative or a minus 40. And all over 2 times 2, which is 4. So what happens here? Well, what is 16 times, or sorry, not 16 times 40, but 16 minus 40 is a negative 24. And the reason that I know that this one is not going to have any solutions is because of this guy right here, the square root of the negative 24, okay? Because I can't square root a negative without using complex numbers or imaginary numbers, this is going to have no solution. So because of this guy, we're going to have no real solutions because I have a square root of a negative and I cannot do that. So kind of leading into that is our discriminant and quadratic equations. So what is the discriminant? What's the point of it? Well, the purpose of a discriminant is to have a quicker way or a quick way to determine the number of solutions of the quadratic equation. Okay, ax squared plus bx plus c. Our discriminant is this. So this is what the discriminant literally is. It's it's b squared minus 4ac. If b squared minus 4ac is greater than 0, if you calculate that, and remember, that is all that is here's our quadratic equation, right? Or quadratic formula, negative b plus or minus b squared minus 4ac all over 2a, okay? Our discriminant is this guy. Doesn't include the square root. It's what's inside the square root or inside the radical. So it is this guy. This is our discriminant. And when I'm determining the number of solutions of a quadratic, it's all based on what the discriminant is. So if this all simplifies the b squared minus 4ac, if that part, what's inside the radical, simplifies to greater than 0, to a number greater than 0, there will be 2 real solutions in your quadratic equation. If it simplifies to 0, there will be one real solution, and we saw that already. If it simplifies to something that's less than 0, there will be no real solutions. There will be 2 complex solutions, and we'll talk about that in a little bit. But let's go back and look at some of these questions, okay? This first one, okay? What did our discriminant simplify to? Well, it simplified to a positive 49, right? So what was inside the square root was a 49 in our first example. Well, I know that if the discriminant is greater than 0, what does that tell us? Okay, it tells us that there will be 2 real solutions, and that's exactly what there was in our first example. Okay, there were 2 real solutions, 2 and negative 5. Okay, and the next one, we kind of had the same thing. Our discriminant simplified to the square root of 137, or just, sorry, the discriminant is only 137. It's what's inside the radical. And that's greater than 0. So we have 2 real solutions, right? Well, in the next one, our discriminant, what happened there? It actually simplified to 0. And that tells us what? It tells us if the discriminant simplifies to 0, then there is 1 real solution. And that's exactly what happened in this equation, right? We had 36 minus 36, which was 0. And it ended up being that our solution was only x equals 1. So we had 1 real solution. And then in our next problem, we had that the discriminant simplified to negative 24. And when you have a negative inside of a radical, that tells us that there are no real solutions. So that's what happened there, okay? So that's the discriminant. There would be 2 complex solutions, okay? And I will show you some complex solutions when we have something like this here in a little bit, okay? But basically, you would be working with the number I, right? Like we've done in the past, back in chapter 10. So let me go ahead here and do this example. We're going to use the discriminant to determine the number of solutions to this quadratic equation. And then we're going to solve the equation using the quadratic formula. Because, well, why not, right? So if we're already, finding what the discriminant is, why not just go a little bit further and use the quadratic formula, right? So the first thing that I have to do in this quadratic is I have to move this 3 over to the other side. I have to get this so that it looks like standard form of a quadratic. So I have negative 2x squared plus 5x, and then I subtract the 3 and set that all equal to 0. Now, I'm going to define all these, right? So A is equal to negative 2, B is equal to 5, and C is equal to negative 3, okay? Now, the discriminant is only B squared minus 4AC, okay? So all you have to do here is substitute right now into this, okay? So what is it equal to? Well, B squared, so B squared. B is 5. So I'm going to square 5 minus 4. Notice I've always been putting parentheses around the 4. That's just a habit. I think it works out better on your calculator. So it might be a general tip or something that you can do. And then I have A, which is negative 2, and C is negative 3. So what does this simplify to? Well, this simplifies to, let's see, 5 squared is 25. And then negative 4 times negative 2 is positive 8. Positive 8 times negative 3 is negative 24. So 25 minus 24 is 1. So what does that tell us? Well, it tells us B squared minus 4AC is equal to 1. Okay. And when B squared minus 4AC is equal to 1, which is greater than 0, it tells us there are 2 real solutions. So because 1 is greater than 0, I know that there will be two real solutions to this quadratic equation. Okay. I know that for a fact. Okay. Now what I'm going to do is I'm going to continue this problem using the quadratic formula. So again, our quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And let's substitute. So we're still using the same a, b, and c here. So b is equal to 5. So I have negative 5 plus or minus. Well, I just found what this all is, right? B squared minus 4ac. I found that that's 1. So let's just put 1 underneath the radical. And then I have 2 times a, and a was negative 2. Okay. So really here, let's simplify a little bit more. I have negative 5 plus or minus the square root of 1. The square root of 1 is just 1. All over 2 times negative 2, which is negative 4. So I have two different solutions here. I have negative 5 plus 1 all over negative 4. And, whoops, and I have x equals negative 5 minus 1 all over negative 4. So my two solutions here are, well, it's negative 5 plus 1 is negative 4 all over 4. And x equals negative 6 over negative 4. And those two together, whoops, let me just scribble that out, are negative 1, and negative 6 divided by negative 4 is a 3/2. Simplifies the 3/2. Okay. So let's see here. Did I do something wrong? Oh, yep. This, sorry, was a negative 4. So then this would actually be a positive 1. Sorry about that, if that was confusing for you, because I made a mistake. So that would be x equals 1 and 3 over 2, or 3/2. Or you could say 1.5 if they don't mind you putting a decimal. All right. So I'm only going to do one problem on the discriminants. Remember, I did show you examples from our past problems of when the discriminant equaled 0, right? And then when it was also less than 0. So that's what I was trying to say. All right. The other thing now is complex solutions. So we can now define complex solutions for quadratics, okay? And this is how. So we use the imaginary number I. So if I have this equation, x squared plus k is equal to 0. If k is greater than 0, our solution to our equation there can be given by x is equal to plus or minus I times the square root of k. And you might recall earlier in the chapter, we had a question like this, where it was x squared equals negative 10, and we were doing the square root property. And this one, we actually said, yeah, we can't take the square root of a negative, right? We can't square root both sides because the square root of negative 10 is, we can't do that, right? We can't take the square root of a negative number without complex numbers. So this is, yeah, this is going to have no real solutions, right? But what you can do is you can square root this now, okay? And that's what we're doing with this property, okay? So I can square root this. And I know now that, well, remember what I equaled? It equaled the square root of negative 1. So if I go ahead and I break up the square root of negative 10 into the square root of negative 1 times the square root of 10, then the square root of negative 10 is equal to I times the square root of 10. Okay, so this is what? Well, this now, if I square root this, it's plus or minus I square root of 10. So that might be the only little difference here. If I square root this when it's in equation form, I do have to put the plus or minus in like we've been doing all chapter, okay? So that would be the solution to x squared equals negative 10. Now I could do a problem like this, right? So they give us x squared plus 17 equals 0. Well, all I would do to start that is move the 17 over and make it negative. and then I can square root both sides. And when I square root that, this gets a plus or a minus. So it's it would be equal to plus or minus I times the square root of 17. So one of the solutions would be I square root of 17. And then another solution would be negative I square root of 17. Okay, so kind of like that. And generally we do put the I in front of the square root. We could put it behind, but sometimes if we put it behind, that tells people, oh, the I is inside the radical, where it's actually not. Okay, so basically, in order to tell people, yeah, the I is not inside the radical, we put it in front of it. It just makes it look a little bit better. It just looks better. So let's do a little bit more of a tougher one here with these complex solutions. So solve 3x squared minus 7x plus 5 equals 0. Write your answer in standard form. Well, what does standard form mean? It's standard in complex, right? Complex number, complex standard form, excuse me, is a plus bi. So this one, oh, I'm already writing A, B, and C. Why am I doing that? Because I know that this is not factorable, right? There's no factors of 15 that give me a -7. So I have to try to solve it using some method, well, quadratic formula in this case. So A is equal to 3, B is equal to -7, C is equal to 5. Okay. So let's go ahead here and let's use our quadratic formula to simplify this down. And again, the reason I'm doing this one is because we are going to get complex solutions. Okay, so no surprises here. I'm telling you what's going to happen. Okay, so we have negative b, so negative times a -7 plus or minus, be careful on this part, right? You have a negative and then a -7 plus or minus b squared, well, b squared, so -7 squared minus 4 times 3 times 5. I never seem to make the radical long enough there. And then 2 times 3. I have negative, whoops, not a negative. I have negative times -7, which is going to start us off here with a +7 plus or minus square root of, well, -7 squared is 49. And then 4 times 3 is 12. 12 times 5 is 60. So this is actually -60. And it's a minus again because we have one minus sign. All over 2 times 3, which is 6. And I know that 49 minus 60 is -11. And now that I know about complex number solutions for quadratics, I can take the square root of -11, right? And I can make it into I times the square root of 11. So this is going to be equal to 7 plus or minus I times the square root of 11, or just I square root of 11, all over 6. And I need to write it in standard form. So I'm going to break this up into two different solutions. One is 7 plus I square root of 11 over 6, or you can break it up as 7 over 6 plus I square root of 11 over 6. And the other solution is going to be 7 over 6 minus I square root of 11 over 6. So you can kind of see how I'm breaking that up here. Taking the 7, putting it over 6, taking the I square root of 11, putting it over 6. One's positive and one's negative. And those are your two solutions for x here. So x equals those things. Okay. And those are in standard form, again, because it's an a plus bi. Some people, you could write the I in front there. So you could write 7 over 6 plus the square root of 11 over 6i like that. Or again, like this with the minus. I'm not so picky about it if the I is in front, because I told you to put it in front earlier, but you could also put it behind in this case because you do have that fraction. So I'm not really picky about it. I don't think my lab math is picky about it, but just in case, just so you know. All right, now we have a couple more problems, and I put this one in there because this is a completing the square problem that does deal with the complex numbers now, okay? So that's why this is in here. So let's start this. We need to square, or sorry, we don't need to square. We need to distribute this x. So let's distribute the x in. So x times x is x squared. X times 4 is negative 4x here, or this with this negative sign. And that equals negative 5. Well, how did we complete the square here? Remember, we did b over 2 squared. And I need to add that number, right? I need to add it here, and then I need to add it here. So let's go ahead and do that. Let's find what b over 2 squared is. So in this case, it is what? Well, what is b? B is equal to the negative 4. So b equals negative 4. So I substitute negative 4 in for b, and then I square it. So negative 4 divided by 2 is negative 2. And negative 2 squared, quantity squared, is positive 4. So I take this, I have x squared minus 4x, and I just found that number 4 that I want to add on both sides of that equation. So again, if you don't remember completing the square, look back at last section. We did that pretty much all last section. And then here, the reason I completed the square was giving us a perfect squared trinomial on the left. So that factors down into x minus 2 quantity squared, and negative 5 plus 4 is negative 1. But look, now I can use our square root property, but the problem before was this is a negative. So all the examples I gave you last section, this was a positive, so it wasn't a problem. Well, now it's an issue because it's a negative, but we don't really have to worry about it that much because we have, or we can use complex numbers. So when I square root both sides, this is now, well, it's x minus 2. It was always would have been x minus 2. But then the square root of negative 1, I know is I, but I also have to, when I square root, I have to plus or minus this. So it's plus or minus I. All right. And then I add 2 to the other side. So really it's 2 plus or minus I would be our answers. So one of your answers is 2 plus I, and then the other answer is 2 minus I. And the reason I wrote it again with the I in the back is because our standard form is A plus BI. So I want the I term last, And there's no coefficient this time that goes next to the I because it's simplified down. The square root of negative 1 was I. So I didn't have to do anything there. So, all right. Now I have a couple of just homework questions where, they'll say, hey, use the method of your choice. So you guys are kind of lucky where generally on a quiz or a test, I'm going to put these in order, right, of each section, starting on section 11.1 and going to 11.4. But they might give you problems here in your homework. Well, it's where it's like, well, why don't you pick the method of your choice, the method that works the best? So remember kind of our methods for solving quadratics were graphing. We did factoring, right? We did the square root property. We did completing the square. And now we did the quadratic formula. Okay, well, this one, we have 2 basically perfect squares. So I think for this one, we're going to be using the square root property. Okay, so let's go ahead. Remember the square root property, the whole point was to get x alone. And to start that here, I'm going to add the 9. So I have 49x squared equals 9 when I add it to the other side. Then I divide both sides by 49. So I have x squared equals 9 over 49. And now I can square root both sides. And again, when I square root in this section, it's got to be a plus or minus. So I have plus or minus the square root of 9 over 49, which breaks up, right? This breaks up into the square root of 9 over the square root of 49. And that tells us that this is equal to, well, the square root of 9 is 3, the square root of 49 is 7. So my two answers here are x equals positive 3/7 and x is equal to negative 3/7. All right, and then I just have one last example. And I know the words are a little bit small here, but I did want to do this so you can follow along on your homework with it. And again, your numbers might be a little bit different than mine. But from 1989 to 2010, global music sales S of compact discs and tapes in billions of dollars can be modeled by this formula, or this equation. S of x equals negative 0.082x squared plus 1.79x plus 4, where x is years after 1989. Estimate symbolically when sales were 9 billion. So they want us to estimate when sales were 9 billion. But remember, x means years. So I can't, and this is probably the biggest mistake here, I can't just go ahead and substitute 9 for x, because those don't mean the same thing. I want to estimate the sales, but x is years. So what I have to do here is I have to substitute this guy, this 9, in for s of x. So I start this problem by saying that this is 9 equals negative 0.082x squared plus 100, not 179, but 1.79x plus 4. And now what I do is I subtract the 9 to the other side. So I have negative 0.082x squared plus 1.79x. And then I subtract 9 from 4. So I get a negative 5. And now what I'm going to do here is I want to estimate when, right? I want to estimate when the sales were 9 billion. So I do want to find x, okay? So I do want to find the x years. So I have to use the quadratic formula here to be able to find x. So let's do this here. So our a value is equal to negative 0.082. Our b value is equal to 1.79, and our c value is equal to negative 5. So I have x equals negative b, so negative 1.79 plus or minus the square root of 1.79 squared minus 4 times our a value, and then times the c value, negative 5. And that's all over 2 times the a value. And I know this looks a little bit weird right now, but we'll figure it out. So this is negative 1.79 plus or minus. When you simplify everything on the inside of the square root here, okay, you can just type this all into your calculator if you want. At the same time, inside the square root, you're going to get 1.5641. And then underneath here on the bottom, 2 times negative 0.082 is negative 0.164. And then I'm going to keep simplifying here. So I do this, and I'm going to get, where's my calculator? Here it is. The square root of 1.5641. Well, that's a really long number. So what you want to do here is you want to type all this in at once. So you want to do negative 1.79 plus, so you want to do, so one of them is negative 1.79 plus the square root of 1.5641 all over negative 0.164. 164. And what you can do here is you can put this top part in parentheses, and that'll help it help break it up. And then the other one here is going to be negative 1.79 minus the square root of 1.5641 all over negative 0.164. So again, use parentheses here. So the two values that I got when I did that were 3.289 and x is equal to 18.54. Now in this case, okay, the question says X years after 1989. Estimate symbolically when the sales were 9 billion. Well, these two numbers represent years after 1989. So really what I would be doing here is I would be doing this. I would be taking this number, okay, and I would be doing 1989 plus, well, this is closer to 3. So this would be plus 3 years. So 1992. And then I would be taking, again, the 1989, and I would be adding 18.54 is closest to 19. So 1989 plus 19 would be 2008. So those would be your two answers there, 1992 and 2008. And that's that homework problem. Again, you might have different numbers there for your question. But that is chapter 11. Again, I know it was a little bit longer. You know, we only had 4 sections, so that's kind of the way it works out sometimes. You know, you kind of give and take, right? If you have less sections, the lectures are going to be longer. If you have more sections, the lectures will be shorter. But that's chapter 11 on quadratics. Again, we learned a number of different methods this chapter. We ended with the quadratic formula. If you have questions, please reach out to me. I'm available through email. You could schedule a time to meet with me. Just say, hey, Nick, I would like to meet, and we can find a time that works. So otherwise, have a great rest of your day. And we'll see you for the chapter 11 review prior to taking your next exam. So until then, see you next time.